Hello and welcome to Textbook Engineering Problem. Today we're working out of Elementary Principles of Chemical Processes, 3rd edition, and we're doing problem number 7.1. We skipped chapter 6 because somebody asked me to do all of chapter 7, and I haven't gotten any other requests. So if somebody really wants chapter 6, you just got to put it in the comments. If I get more people asking for chapter 6 stuff than chapter 7, then I can go back and do chapter 6, but for now people are just asking for chapter 7, so I'll just go ahead and keep on with that. Doing problem number 7.1. This one's pretty quick, so I'll go ahead and read the problem statement. It says a certain gasoline engine has an efficiency of 30%. That is, it converts into useful work 30% of the heat generated by burning a fuel. If the engine consumes 0.8 liters per hour of gasoline with a heating value of 3.5 times 10 to the 4 kilojoules per liter, how much power does it provide? Express the answer in both in kilowatts and horsepower. Okay. So here, this is my little symbol epsilon, saying epsilon is 0.3. Okay, because that's 30%. Okay. Then they give us this value, this volumetric flow rate, and they said that 0.8 liters per hour of gasoline is flowing into the engine. Okay. Then they said a heating value. They haven't really defined that, and I don't think they define it in this chapter, which is a little odd. But if you look in the appendix, not the appendix, the index, you look up heating value, then they give this value for heating value. Basically what heating value is like you combust a gasoline and it gives off a certain amount of energy. Okay, so you combust gasoline, or it doesn't have to be gasoline, it could be any fuel. You combust a certain amount of fuel and it gives a certain amount of energy, all right? Well, they told you that 30% of that energy becomes work, okay? So if you multiply the efficiency times the heating value there, then you get the total amount of work, okay? They said that the heating value is this, okay? If you think about that, that makes sense, this relationship here. It makes sense because, like, okay, so I'm putting in all this energy. I mean, you're putting in more energy than just the heating value of the fluid, because there's also like the kinetic energy and the potential energy and, like that kind of stuff. But kinetic energy and potential energy usually are much smaller values, like potential energy from like gravity, much smaller than the amount of energy that's released from a chemical reaction, right? It's almost comparable to how much energy is produced in a nuclear reaction versus how much, compared to chemical. Okay, so you get a certain amount of energy from like dropping a ball. You get a certain amount of energy from burning the ball. And then if the ball was made out of nuclear, like uranium, and you used fission on that, then that would be like humongously way bigger than, any of those things by like 1,000 times, right? So it's kind of the difference. So usually chemical energy is much bigger than potential energy. Okay. Potential, like gravitational potential energy or kinetic energy. Not always, but most of the time in the circumstances when we're working in these situations. Okay, so 30% times how much energy is released from the chemical reaction gets turned into useful work in this engine. So we just multiply 0.3. Big, long explanation for a very simple problem, but I just wanted to help you grasp some of the stuff that you'd be using here. Anyway, then the rest of this is just unit conversions. 3.5 times 10 to the 4. Hopefully I do my calculator stuff right. I do make mistakes there, here and there, so if I mess up, you just put something in the comments. I will pin your comment. But hopefully I've calculated everything correct here. Then we convert it into horsepower. Okay, turn our kilowatts into watts, and then this is the metric that they give in the book. You could also probably just do it in Google, but there you go, horsepower. All right, that's it for problem number 7.1. Thanks for joining me. Don't forget to like and subscribe, leave a comment, whatever. I appreciate the feedback and also the requests. It makes easier to pick which topic I'm going to go over. So thanks for everybody's comments and support. And I hope you have a good night.